Subscribe to Careerflite and press the bell icon to never miss our videos.
Hello students, we are here with a new video here in the geography class series, and this is the Careerflite initiative of geography civil service classes, and I'll request you to please share the video with your friends and subscribe the channel. So let me start the class here. The topic of the today's class is solar radiation, heat balance and temperature. So here we're going to start with the radiation. When I say solar radiation, it means the radiation that comes from the sun. Now we're going to see how this solar radiation that comes from the sun. Okay, it can be divided in two parts. The coming of the sun. The sun rays that is coming from the sun directly on the surface of the earth. And the part of the sun rays that is reflecting back from the surface of the earth. So there's radiation of the sun. One part is coming directly from the sun, the another part is reflecting back from the surface of the earth. This part of the solar radiation is called insolation. Insolation. And this part of the solar radiation is known as terrestrial radiation. Terrestrial radiation. Insolation means incoming solar radiation. Okay, incoming solar radiation, and the reflected part of the radiation is known as terrestrial radiation because it is reflecting back from the terrestrial part. So this is about the radiation. Now we are going to see how this insolation and terrestrial radiation is responsible for the distribution of temperature on the Earth's surface. As we can see on the surface of the Earth, the temperature is different in different zones. So you can find maximum sunlight in some part in the tropical areas. When I say tropical area, it means the area between tropic of Cancer and tropic of Capricorn. So in these areas, tropical area, you can find maximum sun rays, and in the frigid zone near the polar area, you can find very less temperature. Okay, so the amount of temperature, the heat, sunlight that is we are getting in this area is much higher than this polar areas. So temperature should be very high here. It should be very warm, very hot here, and it should be very cold. Means every time it should be frozen. This mid latitude or this one the high latitude countries should be frozen, but as we can see, it is not frozen, and it is also not very high hot that we cannot survive. Why it happening? Why it is happening? Because there is distribution of heat. The heat is being distributed from one part to another part. The heat is being distributed from one part to another part, and that is how we can find the balance in the temperature and heat. So this class will start from some terms. The first term will be aphelion and perihelion. Aphelion and perihelion. Now what is the meaning of aphelion and perihelion? So as we know, the distance of sun from the earth is 150 million. On an average it is 150 million kilometer. This is the distance of the sun from the earth. But a day come on 4th July. On 4th July, when the distance of the earth from the sun is maximum, it is 152 kilometer. 152 kilometer, sorry, million kilometer. 152 million kilometer. On this day, 4th July, the distance from the sun and earth is in between sun and earth is 152 million kilometer. And the day on 3rd January, 3rd January, the distance between earth and the sun is minimum, that is 147 million kilometer. So this the longest distance on the 4th July is known as aphelion. This position of the earth from the sun on the 4th July is known as aphelion, and this position, the shortest position, the shortest distance between earth and sun is known as perihelion. Okay, these are the two points, two terms that we can see, aphelion and perihelion. Now, what is the effect? But we cannot see the effect of this aphelion on 4th July. If we talk about the northern hemisphere in 4th July, it is, though it is far away from the sun, 152, it is the long distance is more, but still we can say that it is hot summer here in northern hemisphere. And on 3rd January in our part in northern hemisphere, again on 3rd January it is winter. Though the distance is less, though the distance is less, we are having winter here. Now, what can be the reason? Because the distribution of heat on the surface of the earth is decided by many different factors. Okay, the distribution of heat on the surface of the earth are decided by many different factors. One of them is distribution of land and sea and the air circulation. Okay, mostly air circulation and distribution of land and sea distribute the main heat and temperature around the earth. So the effect of aphelion and perihelion is masked. The effect of perihelion and aphelion is masked by the effect of air circulation and distribution of seawater and landmass. Now, if we talk about the amount of power that comes from the sunlight in different zones, there is a sunlight, and how much amount of power is coming at different zones or latitude. This is the mid latitude. Suppose this is the mid latitude. This is the equator. This is the mid latitude, and this is the high latitude polar area. Pole. So we can see more sunlight here in this zone, tropical zone. We can find more sunlight here, and the power energy is very high here, 720 watt per meter square. Per meter square in this zone, in the tropical area, you can find 720 watt power per meter square. Sorry, not 700, 320 power per meter square. But here you can find 320 watt per meter square. Here you can find 70 watt per meter square. Okay, you can find 70 watt per meter square in this polar area. Though the power is very high here and it is very low here, still it is not getting very, it is not getting frozen. This polar part is not getting frozen and this part is not getting very hot. Why? What is the reason? Because heat is being distributed. There is a distribution of heat and there are different factors who help in the distribution of heat. And if I say about the high amount of heat, insolation, which latitude gets high amount of insolation? If we divide the earth into different latitudes, starting from equator, this is the equator at 0 latitude, 0 degree latitude. This is the tropic of Cancer at 23 and half degree north latitude. Then again tropic of Capricorn at 23 and half degree south latitude. And if you get a question in prelims that which latitude will have more insolation, as you know, sun keeps on, apparently moves in between Cancer and Capricorn. Sun, that's the rays of sun, we can find overhead in these zones only, in this area only, in between Cancer and Capricorn. So you can find the sunlight is going in the polar area in the slant direction. They are moving in a slant direction, they are making an angle in this direction. But here we can find mostly the sunlight in this tropical area. This zone is tropical area. Now this is the insolation. Okay, this is the incoming solar radiation. And if someone asks you, or the prelims, in prelims you get a question where the insolation will be high, so the insolation will be high in this zone nearby the subtropical zone, nearby this tropic of Cancer and Capricorn, not at the equator. Why not at the equator? Insolation, because the equator will have lots of, the temperature will be high here, and because of that there will be lots of evaporation will takes place here. And because of this evaporation, the water molecule will go up and they will make clouds, and this clouds will reflect back lots of the sunlight insolation. Okay, lots of the insolation that will reflect back from these clouds. That's why you can find more insolation in this subtropical area, not in the equatorial area. Now, what are the main factors that decide the distribution of heat? First one, you can say axis of the earth. Axis of the earth. Okay, now then slant rays. Slant rays of the sun. Then there are small factors, not very major factor, like transparency. Transparency of the atmosphere. Then distribution of land and water. There are also minor factors that decide the distribution of heat on the earth. Now, how the axis contributes in the distribution of heat? As you know, there is an axis, there is an imaginary line here. There is an imaginary line that is going through Earth. An imaginary line that is passing through Earth is known as axis. And this axis makes an angle of 66.5 degree. Okay, it makes an angle of 66.5 degree with the revolutionary part, the plane. With the revolutionary plane, the axis make an angle of 66.5 degree. It means the Earth is tilted. It shows that the Earth is tilted. Okay, means the axis is not passing directly. The axis जो है axis, it is not passing through directly from north to south. It is actually, this axis is actually moving with a tilt from this direction to this direction with an angle of 66.5 degree. And because of that, because of this axis, we can find different seasons in the world. In the earth, we can find different seasons both in the northern hemisphere and southern hemisphere. The seasons, summer, winter, spring, or autumn season, are decided mostly by this tilting of the axis. Now how it contributes, let us see. This is the sun, and on the day of 21st June, this is the day of 21st June. Now what is happening on the day of 21st June? The earth here, suppose it's the earth, it is tilting in this manner. Okay, the earth, if you show, if I can show you the earth with this axis, then this is equator, this is Capricorn, this is Cancer, sorry, this is Cancer, this is Capricorn. Okay, if I draw the line perpendicularly, axis line perpendicularly, in this perpendicular to the revolutionary path, then this will be the equator, this will be the Cancer, this will be the Capricorn. But here, since it is tilting in this side, it is tilting in this side, so this Cancer, Capricorn, this line also will move according to the tilting of this axis. So Cancer will be here, equator will be here, then Capricorn will be here. So on the day of 21st June, we can find the sun rays directly above the Cancer, Tropic of Cancer. The sunlight will be overhead Tropic of Cancer. So if you are present in the Tropic of Cancer, you can find the sun is overhead you on the day of 21st June. Okay, and in northern hemisphere, because Tropic of Cancer is present in the northern hemisphere, so there will be more heat in this northern hemisphere, and we can find summer season here in northern hemisphere. It will be summer in northern hemisphere. Now, as we move, as the Earth will move in this revolutionary path around the sun, this is the revolutionary part of the Earth around the sun, and when the Earth will reach here on September 23rd September, on that day, what will happen? There will be autumn season in northern hemisphere. Now the sunlight will fall directly over the equator now. See, the earth is tilted in this direction. Now it will come here. So it is not falling over the Cancer now. It is falling over the equator now at present. So at this position, there will be autumn season now. Autumn season in the northern hemisphere. You'll find autumn season in northern hemisphere in this position, 24th September, because the axis, as you have seen the axis here, the Cancer is there, so sun rays is falling directly over the Cancer. But at this position, when the Earth will reach here, the sunlight will fall directly over the equator only, not over the Cancer, because Cancer is present in this, tilted in this side. Then again, when the Earth will reach here, again this is tropic of Cancer, equator, Capricorn. On this day of 21st December, we can see that the sunlight is falling directly overhead over the Tropic of Capricorn. The sunlight will fall directly over Tropic of Capricorn. In this position in June, it was over Tropic of Cancer, but here in this position, it will be on Tropic of Capricorn. Now, what happens on this day? There will be summer in southern hemisphere here because there will be more heat in this around this Capricorn zone. So there will be summer in the southern hemisphere and it will be winter in the northern hemisphere. And when it will move and come here on 21st March, 21st March. Now what will happen here again? The equator, the sunlight will fall directly over the equator. Okay, the sunlight will fall directly over the equator. So here you can find spring season in northern hemisphere. There will be spring season in northern hemisphere. So these are different seasons that we can find in the northern hemisphere based on the axis. Why these seasons are forming? Because based on the insolation that is getting from the sunlight. So the distribution of insolation from the sunlight is dependable mostly in the axis of the earth, and this position is known as summer solstice. This position is known as winter solstice because on 31st December it will be winter in northern hemisphere, winter solstice. Here it will be autumn equinox, and it will be spring equinox. Now what is the meaning of equinox? Equinox means equal night. Equal night, it means it will have both at the autumn equinox and spring equinox will have equal night and equal length of the night and equal length of the day. But here in summer solstice we will have longer day and shorter night. Here again in winter solstice we will have longer night and shorter day. So we can divide the seasons of the or of our earth based on this axis of the earth. Now, what is the next factor that decides the incoming solar radiation on the surface of the Earth? That is slanting of the rays, Earth, sunlight. This is the sunlight, and this is the Earth. So, the sunlight will fall directly over this tropical area mostly. They will make a big angle around 90 degree in this area. The angle will be larger here. But as they move towards the polar area, the angle will decrease here. The angle will decrease here, but the angle is bigger here. Okay, so as the angle keep on decreasing, they are making more slant rays here, and because of the slant rays in both the polar area and polar sides, the amount of insolation will be less. First of all, because of this insolation, because of this slant rays, the amount of insolation will be less. Why? It will take a long distance to cover. This rays will take a long distance to cover. It will cover a long distance from here to polar area. If you compare with this equatorial area, the distance will be more to the polar area. Then again, as they move through this zone, they will pass through different types of particles, dust particles, water vapor, all these particles. Then these rays will be reflected back. It will be scattered. Most of the light will be rays will be scattered by these particles here present here. So because of the scattering of the light, again the amount of insolation that will come towards this will be low. And this scattering also is responsible for different colors that we can see on our earth. So that is a region. This is one of the factor that decides the distribution of insolation. Then again, transparency of the earth. Transparency, if the atmosphere is clean, there will be more insolation, and if it is polluted, then the amount of insolation will be less. Again, based on the distribution of land and sea, if more land mass is present, the insolation will be high, the heat will be high if there is more land mass. As we can say in the northern hemisphere, the amount of distribution of land mass is more, so the heat will be more. And in the southern hemisphere, the distribution of water is more. That's why we can find less heat in the southern hemisphere. It is because different capacity of the both water and land mass to absorb the heat. Land can absorb the heat very fast, and it can also release the heat very fastly because of its opaqueness, the nature of opaqueness of the land mass. But the water body, it will take a long time to absorb the heat, and again it will take a long time to release the heat because of its translucent nature. Now we'll see the different factors that are responsible for the distribution of heat in different part of the earth. First, it will be latitude. Now, how latitude will decide the distribution of temperature on different part of the world? First, as we move away from the latitude, as we move away from the latitude, suppose this is the 0 degree equator, then 23 degree half cancer. Then again, as you keep on increasing up to 90 degree, what we can see, the amount of insolation will keep on decreasing. As we keep on increasing the latitude, the amount of temperature will keep on, the amount of insolation will keep on reducing. That's why more will be the latitude, less will be the heat. More will be the latitude, less will be the temperature. Why? Since at this zone, in this tropical zone, the heat insolation is very high, temperature will be high in this zone. So in this zone, the rays will come in a slant manner, in a slant rays direction with an angle. So because of that, as we increase the latitude from 0 to 90 degree, as we keep on increasing the latitude from 0 to 90 degree, the amount of heat will keep on decreasing because of the reduction in the insolation. That is how latitude decides the distribution of heat in different part of the world. And next factor will be altitude. Now, how altitude or elevation will decide the distribution of heat? Altitude. Now, altitude means height. Okay, altitude means elevation. This is the elevation. Mountains, they are having more elevation height. So, you can see in the mountainous areas, if you go to plateau, high plateau areas or mountainous area, we can find that the temperature here is low. In the hilly areas, the temperature is low. But in the plain area, the temperature is high. Plain area temperature is high. Now, how it takes place? Because most of the earth surface is heated up by the terrestrial radiation. The earth surface get heated up by the terrestrial radiation. How? Because of conduction, the process called conduction. Now what is conduction? It is a process through which heat transfer from one layer to another layer when they come in contact. Suppose two layers are in contact, the lower part is the upper part. When they're in contact, physical contact with each other, the temperature of this lower part, if it is high in temperature, then the temperature will move towards the upper part. That is through conduction. Through conduction, temperature is, it is increasing the temperature of the another layer. That is the process called conduction. Again, because of terrestrial radiation, when the sunlight comes here, it fall down, then again it reflect back. Okay, it reflect back. That reflected part is called terrestrial radiation. Now as it moves towards the upper part, it keeps on hitting the surface. First it hits the surface of the earth. This insolation will first hit the surface of the earth. Then again, the air that will be in contact with this surface of the earth, it will get heat up. This layer of the air will get heat up. Then again, this layer of the heat will get heat up. Then again, this layer will get heat up. Through this process of conduction, the one by one, each and every layer will keep on heating. And as the distance keep on increasing, the amount of heat will keep on decreasing. Okay, this layer will have more heat compared to this layer. Again, as we keep on moving towards the upper part vertically, so the heat will keep on decreasing. That's why in this high altitude areas, the amount of heat that goes here will be less compared to this nearby the landmass. So the heat nearby the earth will be more as compared to the heat at the mountainous area. Why? The terrestrial radiation that will heat up the surface, it will be more here. The heat will be more here. So as the terrestrial radiation move towards the upper part in a vertical direction, what will happen? The amount of heat will keep on decreasing, and as it reaches this mountainous area, top of the mountainous area, the temperature will be very less. That is why in the mountainous area the temperature is low. Now, what are the other factors that decides the distribution of temperature? We have talked about latitude and altitude. The next is distance from the sea. Distance from the sea. Now, the coastal area, they are very closer to this coastal area, they are very close to the water body. The landmass, the peninsular part of India, they are very closer to the water body. And the interior part of the landmass, suppose Delhi, they are in the interior part of the country. They are the interior part surrounded by landmass mostly. And this part, coastal area, suppose Mumbai. This is a coastal area in the southern part, right? In the western India, this is a coastal area. Now, what is the effect from the distance from the sea? As we move away from the sea, the extremity in temperature increases. Okay, the extremity in temperature increases as we move away from the sea, because the sea, the water body, that what they do, they moderate the climate. Water bodies, they moderate the climate of a particular place. The job of water body is to moderate the climate. It has a moderating influence. Moderating influence. How it moderate the climate? Because there will be difference in the pressure. When there will be different heat, different types of insolation, both under land, this is the land, and this is the water. Okay, when insolation will come, there will be different generation of different types of pressure, both over the land and over the water body. How? over this land, this will get hit up very early. This land will get hit up very early, and because of that, this molecules, the air molecules, will absorb the heat and they will become light, and because of that, they will rise up. These air molecules will rise up, and because of that, the pressure here will be low. It will be low pressure because the air molecules, the pressure that is exerted by the air molecules, they got raised up, and because of the upliftment of the air molecules, the pressure here will be low. And again, this water molecules, because it takes a long time, the water molecules takes a long time to warm up because of its translucent nature. It is opaque, it is translucent, it will have to absorb lots of heat to get warm up, so it will take a long time to warm up. At the time when this landmass is warm, at the time it will be cold, the surface of the water will be cold, so the pressure will be here high, because air molecules are nearby this water body only. The pressure here will be high, so there will be movement of wind from high pressure to low pressure. Next, there will be movement of wind from high pressure to low pressure. So though there is temperature is high in the beginning, this temperature will be moderate by this cold wind that will move from the water body, that is known as sea breeze also. Then again, in the same manner, during the evening time, the water body is still warm. The water body is still warm, and the land mass is cold, because it releases the heat very easily during the evening. In the morning, it absorbs the heat very fast, and during the evening, it releases the heat very fast also. So it will become cold very early. But in case of water, the water, as they take a long time to get warm up, in the evening they will take a long time to release the heat. So in the evening time, it will be warm in the water body and it will be cold over the soil land mass. Now next, what will happen? Cold means high pressure here, then warm means low pressure here. So there will be movement of wind from high pressure to low pressure. It is also caused, also known as land breeze, because the cold wind from here will move towards the water body. That is how these water bodies do not allow this landmass neither to cool down very drastically nor to warm up very in a high amount. The temperatures, they do not allow, this water body do not allow the temperature of the landmass to get extreme. Okay, during summer it will be average, the moderate climate will be there. Even in winter also, there will be not a very high range of summer and winter temperature. But if you see the interior part of the country, for example Delhi, Amritsar, all these places, Lucknow, they are interior part of the country, land breeze and sea breeze, because of presence of water body nearby these cities. But in this interior part of the country, there is not enough this big water bodies, so there is no moderating influence here. We cannot find any moderating influence of the water bodies in this interior part of the country. That is why we can find extreme climate. Extreme climate means it will be very high, the temperature will be very hot during summer, and it will be very cold during winter. During summer, the temperature here will be very hot during summer, and during winter it will be very cold. Why? There is not enough water body, not any big water body that can moderate the climate here. But here in Mumbai, you can find around 35 degrees Celsius during summer, around 20 degrees Celsius during winter. So this water body is managing here the temperature, moderating here. But in Delhi, it can be around 45 degrees Celsius, more than 45 degrees Celsius during summer, then again around 10 degree during winter. So you can see the range is very high here, but here the range is low. It is around only 15, it is 35 around. So that is the reason why the importance of water body, presence of water body. As we move away from the sea, the extremity in temperature increases. We can find extreme temperatures, very hot during summer and very cold during winter. These are called extreme temperatures, and this kind of climate inside the interior part of the continent is also known as continental climate. Continental climate. And if someone say what is continental climate means this kind of climate, the climate that a city or a location will have because of its distance from the sea. Okay, this kind of places like Delhi, because since they are far away from the effect of water body, so they will have a continental type of climate, means very high temperature during summer and very low temperature during winter. Then presence of air mass and ocean currents. Air mass and ocean currents also decide the distribution of temperature. Air mass and ocean currents. So air mass, some of the air mass can be hot, some of the air mass can be warm, and some of the air mass can be cold. Air mass means a huge pile of air. Air mass means a huge mass of air that is present over a surface. It may be the surface may be of water body also, it may be also of solid of land mass. The air mass may be present over land mass also, or it may be present over water body also. And whenever it is present over a warm water or even over a warm soil, warm land mass, it will absorb the temperature from that land mass from the surface, warm land or warm water. And again, it will also absorb the humidity from that place. If it is a dry area, then it will have a low humidity of this air mass, and if it is a wet area, then the humidity of this air mass will be high. And again, this ocean current, again ocean current also be warm ocean current and cold ocean current. So there are piles of water that moves over the body of the sea. Cold ocean current. So if this air mass or ocean current moves from one place to another place, it will again distribute the temperature from one region to another region. Suppose warm air mass is moving from a warm place to a cold place. A warm air mass is moving in the air from a warm place to a colder place. So it will increase the temperature at the cold place in the colder region, so that it is distributing the temperature from the warm area to the cold area. Again, if a warm ocean current moves towards the coastal area of the cold places, there are some cold places around the world, mostly in the high latitude countries. If a warm current from the tropical area brings the warm current towards the cold countries, cold coastal areas, so it will increase the temperature. This warm ocean current will increase the temperature of this cold coastal areas. Then again, if the cold ocean currents moves from the polar area to the equatorial area of warm coastal areas, so it will decrease the temperature. This cold ocean current will decrease the temperature in the warm areas. So these are just some factors that decides the distribution of temperature over the earth, different places of the earth. Now we're going to see about the heat budget. What is heat budget? Heat budget means this is the calculation that we are going to do about how much insolation, how much energy comes to the surface of the earth, and how much energy is released from the surface of the earth. Means how much energy the sun provides to us, how much energy the sun provides to us, and how much energy we reflect back. Okay, since we cannot accumulate all the energy, this earth cannot accumulate all the energy. If it accumulates all the energy, it will become very hot. And if it release all the energy, it will become very cold. So it also needs some amount of energy to keep with itself. The earth needs some energy to keep with itself in the form of different types of energy. It will be converted into different forms of energy. So this is how they maintain this balance. Okay, we're going to do a calculation and we'll try to see what kind of balance budget they maintain, the earth maintains, and this budget is known as heat budget. What kind of heat budget the earth maintains? Heat budget. Now you're going to see through that calculation how much energy comes on the surface of the earth and how much energy goes back from the surface of the earth. Suppose this is the sun, this is the earth, and this is the sun. Just consider that 100 units of energy is coming. 100 units of energy is coming from the sun. The sun is sending 100 units of energy, and from that energy 35 units will be reflected back before reaching the surface of the earth. Before reaching the surface of the earth, 35 units, once it enters the atmosphere, 35 units will be reflected back. It will be reflected back the space. Why? It will be reflected by some cover, white cover like snow and ice. Ice, ice caps, then snows, then again clouds. This all white reflected body will reflect back around 35 units of the sun rays insolation. So how much will left? 65 units. 65 units of the sun rays left. And among this, from this 65 units of the sunlight, 14% will be absorbed by the atmosphere. 14 units of the sun rays of the insolation part will be absorbed by the atmosphere from the remaining 65 units. Then again 51 units will reach here on the surface. So as you can see, when the sun has sent 100 units of rays, insolation, okay, energy, 100 units of energy towards the surface of the earth, 35 units of the sunlight got reflected back before reaching the earth. Okay, this 35 units got reflected by the snow, then again cloud, then again ice caps. This reflected part of the sun rays is known as albedo of the earth. This is known as albedo of the earth. Albedo of the earth. This is the reflected portion of the sun rays. This is the reflected portion of the sunlight. Albedo of the earth. This 35 units. This is called albedo of the earth. Now from the remaining 65 units, 14 units got absorbed by atmosphere. Atmosphere has absorbed the 14 units. And how much left? Only 51 units left. And the 51 units will be, it will reach on the surface of the earth. Now again from the surface of the earth, this insolation part will be reflected back in the form of terrestrial radiation. This is the insolation, then there will be terrestrial radiation. Now how it takes place? From this 51 units at the time of reflecting back, 17 units reflected back directly. 17 units of the sunlight get reflected directly, and this part of the sunlight is known as, actually this part is, it gets reflected directly towards the space. It gets reflected directly across the space. This 17 one is from this 51 units reflected across the space directly. And how much will left? 34 units. This 34 units will left and it will be absorbed by the atmosphere again. This remaining 34 units will be absorbed by the atmosphere again. So as we can see, from the reflected part, from the terrestrial radiation, at a time it will reflect back from the surface of the earth, you can see that 17 units directly goes towards the space. Okay, it do not interact with any of the particle here. Now the remaining 34 units, it will get absorbed by the atmosphere. Okay, now we'll try to see how much energy has. Okay, 14 units it got absorbed to the atmosphere, then while coming towards the surface of the earth from the insolation part, then while going in the terrestrial part, 34 units got absorbed by this atmosphere from the terrestrial part. If we add both the units that was absorbed by the atmosphere, we can get 48 units. We can say 48 units was absorbed by the atmosphere. Now how much left? 17 units that was got reflected back from the surface of the earth. Again, if you add it, if you add 17 units, it will become 65 units. Means this is the balance. This is the balance sheet. How much has come and how much has left? As we can see, it is only 65 units total. So 65 units has entered, and again 65 units has, we can show the balance, that how much units we have, how much amount of units we have used, and how much units we have left for the space. If you give the balance here, you can see that 70 units is left and the remaining 34 plus 14 units was absorbed by the atmosphere. So we can show that 65 units was absorbed, used completely by the earth, surface of the earth. This is called heat balance, heat budget. Now we'll find a word, a term called isotherm. What is isotherm? Isotherm means isotherm. It is just a line. Isotherm is a line only. Okay, it is a line. That line connects the places having equal temperature. Therm comes the word from the word thermometer. Now, if you say there are some places around the world there are some places. It will have different temperature. Suppose all the places will have different temperature, but there are some regions on the surface of the earth that will have equal temperature. Suppose this 33 degree, 33 degree. All these places, some of the places are having equal temperatures. So if you try to connect all these places having equal temperatures, so there are different places and some of the places will have equal temperatures. And if you try to connect all the places having equal temperatures, this line that will connect all these places having equal temperature is known as isotherm. So isotherm is nothing but a line, and this line will connect. It will connect the places, locations having equal temperatures. And if you try to see the isotherm in both the in both the hemisphere of the world, both in the northern hemisphere and southern hemisphere, if you try to find the isotherm in both the northern hemisphere and southern hemisphere, the temperature, it will be more parallel. You can find more variation in the northern hemisphere in the isotherm, but it will be less in the southern hemisphere. This is the equator. You can find more variation in the isotherm. Okay, the isotherm will move, it will make many curves in the northern hemisphere, but in the southern hemisphere the isotherm will be mostly parallel to each other. Why? Because there are many land masses are present in the northern hemisphere. Because of presence of land mass in the northern hemisphere in a huge amount, you can say that because the capacity of the land mass and water is different, the absorption capacity of heat for both the land mass and water is different, and accordingly the land mass will heat up very early and water will take heat very lately. And because of the difference in the absorption of heat, we can find variation in this northern hemisphere, and because of that we can find different curves in the northern hemisphere. These curves are actually connecting the places having equal temperatures. And as you can see, landmass may have a different temperature, again water body can have a different temperature. Because of that we can find different curves here. But as you can see, in the southern hemisphere mostly it is made up of water body only, so the temperature will be mostly same in different places. The temperature should be same in different places, because it is mostly we can find water body here, so we can find the isotherms parallel here. Now there is a term called inversion of temperature. Inversion of temperature. Now what is inverted? Invert means opposite. Okay, this is inverted means invert karna, inverted, ulta kar dena. Now what we can see that as we keep increasing the altitude, the elevation, as we move towards the upper part, as we start to move from the plain area towards the upper part, high hilly area, mountainous area, what happens generally, the temperature keeps on decreasing. The temperature keeps on decreasing. Why it keeps on decreasing? Because the terrestrial radiation, the 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 heat from the terrestrial radiation keeps on decreasing. Why? Since the earth get heated up by the sun, the this soil, this landmass will get heat up by the sun from the insolation, and once it get heat up, it will keep on emitting the heat, and it will keep on hitting the upper layers of the air. It will keep on hitting the different layer molecules one by another through the process of conduction. And once it reaches the hilly part, upper part, the temperature will be very low, because the amount of heat that will be released from this part will be low. Okay, because the temperature heat is keep on decreasing as we move from the lower part to the upper part. So this is called normal lapse rate. Normal lapse rate, and it is 6.5 degrees Celsius, 6.5 degrees Celsius per 1000 meter. It means as we move from the plane, from the surface plane area to the upper part, the temperature will keep on decreasing at a rate of 6.5 degree per 1 kilometer. For every 1 kilometer, if we move from the lower part to the upper part, for every 1 kilometer, the temperature will be reduced by 6.5 degrees Celsius. And this rate of decrease in the temperature is known as normal lapse rate. But sometimes what happens, instead of decreasing the temperature from the lower part to the hilly areas, sometimes the opposite happens. The temperature at the upper part increases and the temperature at the lower part decreases. Instead of the normally the upper part should be cold and the lower part should be warm or hot. But sometimes we can find the lower part becomes cold and the upper part becomes hot. And if the opposite phenomenon takes place, we call it inversion of temperature. It means temperature is getting inverted. It is getting inverted. Inversion of the temperature. Now why it happens? In the cold winter night, in a cold long winter night, what will happen? The land will keep on, in a long cold winter night, the land will keep on releasing the heat during the night time. During the daytime it has absorbed all the heat from the sun, and during the night time it will keep on releasing the heat. And a time will come when the heat, all the heat, it will be released and it will go to the upper part. The upper part of the layer will become warm and the lower part will become totally cold. Okay, in this position, when the upper part becomes warm and the lower part become cold, we call it inversion of temperature is taking place. And how we can see, what are the effect we can see? We can find fog here. Even you can find smoke also in polluted areas. When the smoke will combine with this fog, it will form smoke. Okay, because the places here are very cold here. This dust particle will act like hygroscopic nuclei for this water vapor around this area. And because of that, we can find fog and smoke. So as the sun will come out in the morning, when the sun will come out again in the morning, then again when it will warm up this place, the fog will be removed from here again. Normally it will become warm, and it will become again cold. This upper part will become cold and the lower part will become warm during daytime again at a night, when the night will be cold again, cold and winter night, and a long cold winter night, then again this phenomenon takes place. The lower part will become cold, upper part will become warm. It will be again known as inversion of temperature. Now, one more point of inversion of temperature we can say is called air drainage. Air drainage is another example of inversion of temperature. Air drainage. Okay, now what happens in air drainage? From the hilly areas, again in winter time. In winter time, from the hill areas, the air molecules here get heavy. The air molecules in the hill areas get heavy because the temperature becomes very cold here. In the hill areas, the temperature, the high slope get very cold and they become heavy. And because of this heaviness, they'll be pulled by the gravity towards the plain area. The gravity will pull these heavy air molecules towards the plain area, and because of that this cold air molecules will come here and will in the hilly areas. What happens generally, air molecules here will become very cold because of decrease in the temperature during winter night, okay, in the hill areas, and they'll become heavy and they will start to sink. In this plain area the temperature will reduce, so this area will become cold compared to the upper part, warm part. Upper part will be warm here. Okay, before it was warm, but because of this pulling of these cold air molecules from the higher slope towards the lower part by the gravity, then lower part become cold and the upper part remain warm. And this is also a case of inversion of temperature. And this kind of inversion of temperature is called air drainage. Air drainage, because this is like a drain of air, because the air is moving like a drain, like water, flow of water. So this kind of movement is called air drainage. So these are the examples of inversion of temperature. And with this topic I am completing this chapter about this solar radiation, heat balance, and heat balance and temperature. And through this chapter we have seen how the heat temperature is distributed on the surface of the earth. What are different factors that are responsible for the distribution of this heat and temperature, and what are the this one purpose function of exists of the earth for this formation of different seasons on the earth, like this autumn season, spring season, then summer and winter. I hope you have understood the topic, and I'll request you to subscribe the channel and share this video. I'll see you again in the next topic. Thank you very much.